Okay, since I have a working board now, I want to write some programs for it, and I want to have a nice development platform to do that. Originally, I thought I'd just go ahead and use a Zeta CPM computer and use the old tools and do the assembler there, create the hex file, upload it, program it. It seemed a bit cumbersome, and I hate the word processors available for CPM. So I thought, oh, no, 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 I don't want to do that. Let's go ahead and do something nicer. Um, and I thought about getting a cross compiler, and I looked around. And I couldn't really find one that I liked. And then I remembered that the ROM WDBW, that's the software distribution for the Zeta platform and other platforms it supports many, must have used some type of cross compiler. So I thought I'd say, well, that guy was smart. Let's see what he used. So we're looking at the distribution of the ROM WDBW, and this is what you get. Um, the source directory is where the stuff is. We've seen all this before, building the Zeta ROMs. If you look under Tools, though, under Tools, there's a bunch of cool things, and there's something called TASM32, and this is the cross compiler that they used. Um, and it supports many different platforms. It's I'm sorry, it supports uh, 6800, 6502, 8080, 8085, Z80. It supports a whole bunch of different platforms, which is great. So I figure it's good enough for them. It's good enough for me. So I took this directory and I copied it to a location that makes it more convenient for me. I copied it to C colon TASM. So this is my right here. So this is C colon TSM. So everything is under here. So when I go to a command prompt, it's easy for me to navigate to this location, and all the files are there. So let me change windows here, and I'll show you a command prompt. All right, here we are, and we go to the C prompt, and we go to TSAM, and here's all of our files. So if we want to try something out, there is a test 85 ASM. Let's take a look at that. Oops. Type test 85.asm, and it gives us a little program here. Let's see. I'm backing up to see all that's in here. Test 85 ASM. There's some equates. There's an org statement. The only thing a bit odd about this particular assembler that I don't like, it is not exactly Intel ASM compatible. Comments must start with a semicolon, whereas in Intel, they can start with a star. And the equates and the labels and stuff don't need the dots. So you don't need to have dot equate. You don't need to have dot org. You can just have equate or org. And you don't need to have start colon. You can just have start. Works either way. Anyway, there are a few things that are a bit odd about this, but I can overcome those. That's no problem at all. So let's take a look here. We have TASM is the actual um, program, and it has a bunch of flags. So you can choose which processor you're cross-compiling. So here's the list. It's a pretty big list of processors. It's great. And then there's a bunch of other things which I found that I don't really need to know about right now. So we wanted to do the test 85.asm. So we say TASM, and then we said dash 85, which says I'm using an 8085, and I'm going to say test test 85.asm. So if I do that, pass one complete, pass two complete, number var is 0, and then it should have created a list file. So if we do test 85.lst, yes, it created a list file. A list file is the original ASM, and then over on the left here are all of the actual bits that how it compiled it. So we did org 1000, so it starts here at address 1000. No op is 00, LXI is 01, So it's doing the exact same. It's doing a good job. All right. But it did not create a hex file. So I found that if you say T, well, here, I'll just do this. If you do up down arrow keys, you can kind of get a recall. So type 85, I wanted to do this, okay? If I put in test 85.hex and I execute that, now it's actually created a hex file. And if we type test 85.hex, there we go. Actually is an Intel format hex file. So that's exactly what I need. So from now on, whenever I assemble something, I'm going to have to type in the -85 ASM, and yeah, away we go. So that's everything got. And then just for grins, I moved over my monitor program, which is what I'm going to try to get running on this thing. If we do a type 8080.asm, this is the monitor program that I have. So I moved it over and got it to compile. I did have to change quite a few things. First of all, I had to change the comments to make sure they're semicolons. I had to make sure that all of the assembler directives have a dot in front of them, .db, .dw, .eq. So everything needed a dot in front of it. But there's find and replace in modern editors, so that was easy to do. One thing that was kind of a pain was in the old assembler, if you had a multiple ASCII string like these, maybe here's a good example. It's quotation 8080 system monitor quotation. You used the old Intel format, you could have single quotations, you didn't need to have double quotations. So if you have single characters in this particular one, like here, like this quote S, if you have a single character, you can use a single quote, but if you have multiple characters, you have to have a double quote. So I had to change all of those. So that was kind of a pain, but that was the only difficult thing. And then if we do our TASM dash 85, 8080.asm, 8080.hex, boom, it compiles it very, very fast. So if we type 8080.list, whoa, yeah. So you can see here like character turn line feed is DA, and then move is 4D, 4F, 56, 4F, 45. Anyway, it is compiling it correctly. So I now have a good system that I can cross compile on, and then the actual editing of the file I can do outside of the command prompt with WordPad and create it, leave it in this directory, and then come back to cross compile it. Once I get the hex file, then I just use the prom programmer and go from there. So anyway, that's what I've decided on for my development platform.